All right, this next section, we're going to add some more substituents. So we've spent this entire unit so far talking about methyl and ethyl substituents. We're going to add our next two carbon chains, a propyl and a butyl substituent in this section. So far, we've just used methyl and ethyl. They each have only one carbon that can attach to the main chain. That carbon and its bond is circled. So we have methyl, which has one carbon, and ethyl, which attaches in one place to the main chain and then has a second carbon. So with long chain substituents, straight or branched, like propyl and butyl, which we're going to talk about in this next section, different carbons in the substituent may bond with the main chain, affecting the name, but not just the name, also the behavior or the function of the compound. All right, let's start with our next substituent, propyl. Substituents composed of longer carbon chains, so beyond just one or two, so things like propyl and butyl, require us to specify their form and how they attach to the main chain. Propyl and isopropyl have the same chemical formula, C3H7. They each have 3 carbons, but their structures and the carbon which bonds to the main chain differs. To understand how these are named, we need to understand how different carbons are designated. Carbons are named based on the number of other carbons with which they are bonded. So primary carbons are a carbon that is attached only to one other carbon. And we abbreviate it with this 1 and a degree symbol. That means primary carbon. A secondary carbon is a carbon atom attached to 2 other carbon atoms, and written here as a secondary carbon. Tertiary carbons are carbon atom attached to 3 other carbons. So when we write it like this, tertiary. And quaternary carbons are carbon atoms attached to 4 other carbon atoms. And a quaternary carbon is written 4 with the degree symbol, quaternary. So we have these visual representations here of propyl and isopropyl. They have the same formula, C3H7. They attach to our main chain R. So remember in our previous examples where we identified and highlighted that main chain and we had branches coming off of it, just imagine this being a branch coming off of the main chain. But look at the difference here. In propyl, we have in one straight chain where this first carbon is bonded, the carbon that attaches to the chain is bonded to only one other carbon, okay, in the branch. In this case, the carbon that bonds to the main chain, is bonded to 2 other carbons in the branch. So we would call this a primary carbon, and we would call this a secondary carbon. Okay. When the secondary carbon attaches to the main chain, we give it the prefix iso. That describes the bonding to the main chain by a secondary carbon. Okay, so that's why they are both propyl groups. They both have 3 carbons, but this is bonded differently, and so we add that prefix iso. You need to be able to recognize each of these representations, show you that you can properly name each compound of which they are a part. Unlike other prefixes, the I in iso is also used in alphabetizing. So we talked about methyl and ethyl being important and not worrying about di or tri. In this case, the I is used. Okay, so isopropyl would come before dimethyl, for example. Okay, so make sure you are familiar with these representations, whether structural or this line structure formula. You need to know that this is an iso group, okay, that this is a propyl group. Butyl has 4 carbons. Because of that, there are more structures and possible carbons to bond to the main chain. The formula for a butyl group is C4H9. Prefixes are used to designate the different structures and bonding carbons. So if we're going to call it butyl, that is a primary carbon, okay? Primary carbon, where the first carbon for the butyl group is bonded to the chain and then only bonded to one other carbon. If it's bonded to the chain and 2 other carbons, so here's the chain and 2 other carbons, we call that sec-butyl. If it's bonded to the chain and 3 other carbons, so here's the carbon that's bonded to the chain. If that carbon's bonded to 3 other carbons, we call that tert-butyl. Okay, and then if it's the chain, so here's the carbon that's bonded to the chain. And then we have this carbon, which is bonded to 3 other carbons. So the carbon that's bonded to the chain is bonded to 3 other carbons. We call that isobutyl. And the reason is because the carbon that's bonded to the chain is bonded to another carbon here, but then that carbon is bonded to 2 carbons, and that looks like an iso group. Butyl, or sometimes called N-butyl, with the N signifying normal, is the substituent group where the carbon which bonds to the main chain is a primary carbon. Okay, so you just have a one long chain of carbon atoms. Sec-butyl has the prefix sec, S-E-C, signifying a secondary carbon. It's because the carbon that's bonded to the main chain is being bonded through a secondary carbon. Sometimes it's called S-butyl. Tert-butyl, tert signifies tertiary and is due to the bond to the main chain being through a tertiary carbon, sometimes called T-butyl. The sec and tert prefixes are not used in alphabetizing. Okay. So the butyl group would come first if it was sec or tert, because we're looking at that B, not the prefixes. Isobutyl is called that because iso indicates that the carbon which bonds to the main chain is a primary carbon, but that carbon then bonds to a secondary carbon. As in isopropyl, the I in isobutyl is used in alphabetizing. When we're naming compounds that contain a propyl or butyl group, the procedure is similar to that for naming compounds with methyl or ethyl groups. We know that if it has 1 or 2 carbons, it is methyl or ethyl, and that if it has 3 or 4 carbons, it is propyl or butyl. Once we've determined that the substituent group is a propyl or butyl group, we have to determine based on the structure and the carbon to which it bonds to the main chain what form those propyl or butyl groups take. Then once you know that, you can add it to the name in alphabetical order, just like we've been doing, ignoring the prefixes sec, tert, N, but not ignoring iso. So for example, tert-butyl would come before isopropyl because the B in butyl comes before the I in isopropyl. All right, so we're going to go through an example, a few examples, but we'll start with this one where we need to name this molecule that you see drawn in the structure. So just like with every naming problem, our first goal is to identify the main chain of the molecule. And we do that by finding the largest carbon-carbon chain, right? So let's do that now. So I'm just going to start counting. If I start here, I have 1, 2, 3, 4, 5. Now I can go this way and I get 6, 7 either way. So let's see if I can get a longer one. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 6. Yep, so 8. 8 is our longest chain, okay? And so that's right here. We have this main chain of carbons that's 8 carbons long, and we'll call that octane. From here, we have to number the carbons. So you can see we have one substituent group coming off of this carbon right here, and we want to start numbering from the end that's closer to it. So if I start from here, I get 1, 2, 3, 4, 5 carbons away from that end. If I start here, I get 1, 2, 3, 4 carbons away from the right end. So that's the end we want to start our numbering from. So we'll say 1, 2, 3, 4, 5, 6, 7, 8. So indicated on the diagram is the numbering from the previous slide. And again, as a reminder, the numbering starts on the right since the substituent is closer to that end. Now we need to identify and name the substituent. So we have a substituent coming right here off of this carbon. So just want to, as a reminder, this is the parent chain here. This is my R. If you go back a few slides to look at those diagrams, there's an R, here's a C, here's a C, here's a C. Okay? So this carbon is bonded only to one other carbon. So that's a primary carbon. This carbon is bonded to one other carbon. So that's a primary carbon. This carbon in the middle is bonded to 2 carbons in the chain. So that is a secondary carbon. So this carbon connects, or this substituent connects to the parent group through a secondary carbon, and it contains 3, the substituent contains 3 carbons. So a 3-carbon group is a propyl group. And when a propyl group connects to the main chain via a secondary carbon, then we call that isopropyl. Okay, so the substituent is an isopropyl group. In green is a summary of that. So 3 carbons, 1, 2, 3, means that it's a form of propyl. The connection to the secondary carbon in the group makes it isopropyl. So which carbon is that substituent bonded to? Well, we've already done the hard work of determining that, right? It's on carbon number 4. Once we've determined our parent chain, our substituent groups, and the carbons that they've bonded to, we just have to name the molecule. And we've done all the work. So now we say we have one substituent group on carbon 4. So it's 4 isopropyl octane. 4 isopropyl octane. Here's a summary of everything for this first example, and just a reminder that because we have only the one substituent group this time, we didn't have to worry about things like alphabetizing or prefixes and that kind of thing, because we just have the one group. So 4 isopropyl octane. All right, in example 2, we're going to start with the same main chain as used in the last example to try to save ourselves some time. So I've left the main chain highlighted and identified as octane, and the numbers on each of the carbons 1 through 8. So we're on step 3 now, where we identify and name the substituents. So I just want to, I'm going to just draw some carbons, write my carbons in here. So this is carbon. This is a CH3. This is CH3. and this is CH3. Okay, so again, each of these, and then of course this is our parent chain, our R group. So you could go back a few slides and look at the diagrams to see which one looks like this. But first of all, we can see there's 1, 2, 3, 4 carbons, which makes this a butyl group. But now we have to determine what form this butyl takes, and that depends on what kind of carbon this is. So this carbon is bonded to 1, 2, 3 other carbons, which makes it a tertiary carbon. A tertiary carbon. And so we call that tert butyl. Okay, so that's a tert butyl group. All right, so in orange is a summary of that. So 4 carbons means it's a form of butyl. The connection to the tertiary carbon in the group makes this tert butyl. What carbon is this tert butyl group bonded to? Well, because we did our previous steps, we can easily determine it's bonded to carbon 4. All right, now that we've done all of these prior steps, we're in an excellent position to go ahead and name the molecule. So we start with what number carbon our substituent is on. It's on carbon 4. Then it's tert butyl octane. 4 tert butyl octane. All right, so here's a summary again of just everything that we needed to do to get to this final naming of the molecule, 4 tert butyl octane. All right, here's example 3. This is a new chain, so we have to identify and name the main chain or the longest carbon chain. So let's start counting. If I start here, I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And just to make sure, if I start here and go 1, 2, 3, 4, 5, 6, 7. So our longest chain of carbons is 7 carbons long, and we can pick whatever 7 we want as long as they are connected without any backtracking. So 1, 2, 3, 4, 5, 6, 7. And a 7 carbon chain is heptane. Okay, heptane. All right, now that we've identified the main chain, we need to number the carbons, and we start on the end closest to the substituent group, which is here, the branch you can see. So I start on the right, towards the left, I'm 1, 2, 3, 4 carbons away. If I start on the left and go to the right, I'm 1, 2, 3, 4 carbons away. So this chain is right in the middle, so I can start wherever I want. And so just because it's easier to read from left to right, I'm going to start my numbering from there, but it doesn't matter. All right, so since the substituent bonds to the central carbon atom, we begin our numbering on either end, but as indicated in the diagram, I've started from the left and moved toward the right, 1 to 7. Now we need to figure out the name of this substituent group. So we can see it branching right off of the main chain here. We can see that it has 1, 2, 3 carbons. So a 3 carbon group is a propyl group. Okay, and which carbon in the propyl group is bonding to the main chain? If this is our R group, our main chain here, which carbon is bonding? Or how is this carbon bonded? This carbon is only bonded to one other carbon in our chain, so that makes it a primary carbon. And the primary carbon doesn't have any prefix or anything, so this substituent is just propyl. All right, so you can see in orange summarized what we just discussed on the previous slide. Since that substituent has 3 carbons, that's how we know it's a propyl group. And since it is bonding to a primary carbon, we call it propyl and not isopropyl. Now we need to determine to what carbon that substituent is bonded. And since we've done our work here, our pre-work, we can look right here and see it is bonded to carbon 4. All right, so the last thing we need to do is just take all of our steps, all of our pre-work and thinking here, and use it to name the molecule. So we start with our substituent group, which is on carbon 4, so 4-propyl. We don't have any other substituents, so then we can just name to what is this 4-propyl bonded? Our parent chain heptane. So we have 4-propyl heptane. All right, so if you like to see everything all in one place, here is every step of this example where we identified the main chain, numbered it, identified the substituent group and its number, and then finally wrote the name of the molecule, 4-propyl heptane.